Assalamu alaikum, good morning, good evening, wherever you are. I'm Dr. Taha Said, Assistant Lecturer of Anesthesia and ICU in Cairo University, and today our session is talking about an oxygen pathway in anesthesia machine. Okay, let's start our session and let's begin our lecture. We know that most of anesthesia machine is using a dual gas anesthesia machine. Whatever the gases you are using are minimally used at least two gases. Some machines are using three gases. And we know previously from the first lecture that there is two form of gas delivered to anesthesia machine, which is the first form is through oxygen cylinder, or the second form is delivering the oxygen or the gas through the cylinder manifold, which is equal to cylinder tank or gas tank. Both of them are using the pipelines, which is regulated from the beginning at 45 psi. But if we are using the cylinders, so the cylinders are having the psi around 2000 here and here around pressure 2000, and it's regulated before going into machine through the needle valve or the flow meter into 14 for the oxygen and 26 psi for nitrous oxide. This is regarding the gas delivery as we know previously. And here is the medical gas cylinder, which is the cylinder manifold, which is using different or many cylinders at the same time, and these cylinders are connected to the pressure regulator here from the beginning, which is regulating the pressure inside this pipeline into 45 to 50 psi, or the pipeline system directly connecting as gas tank to the an operating system or to ICU to the oxygen pipelines and gas pipelines. Okay, these cylinders in manifold are using cylinders of size H, and they are different, and they are using the DIS safety system, diameter index safety system, unlike these cylinders which is connected at the back of the anesthesia machine, which are using the BIS pen index safety system, and they are of cylinders size E, and they are having a pressure of 2000 psi, and they are regulated inside the anesthesia machine, and they are only used as a backup system. These are not new information. We already discussed them in the session of gas delivery previously, which was the first session in this course. So we are going to one of the most important questions in the exam, which it can come as a written exam, a written question, an oral question, and MCQ question. Paths of oxygen inside the anesthesia machine, they are five passes. Okay, we have five pathways for this for oxygen. First pass of them is the fail safe valve. Fail safe valve is a valve inside the machine preventing delivering of hypoxic mixture to the patient. It is at the end of the circuit of nitrous oxide and is connected to the circuit of oxygen, and it's opened by the pressure inside the oxygen, or it's open but maintained open by oxygen pressure, which is 50 psi, allowing the passage of nitrous oxide through this valve. Okay, if this pressure drop 25, it will partially close. If this pressure dropped to zero, it will stop delivering of nitrous oxide, preventing delivering of hypoxic mixture to the patient, saving the patient. And this will allow the patient to wake up within few minutes later with less hypoxia. I know that there is no oxygen, but at the same time, there is no hypoxic gas delivered to the patient. So it will allow the patient to wake up safely and detect the problem early and avoid hypoxia intraoperative for the patient. This is the first pathway, which is a fail-safe valve. Going to second pathway, which is oxygen pressure failure system, and this is this one. This will detect the low pressure of oxygen. As long as the pressure is maintained inside the circuit, this oxygen entering through this valve, maintaining this diaphragm to be opened and allowing the perfect flow of this oxygen. This system will be activated if the oxygen pressure falls below 50%, which is 25 psi. At this level, the oxygen entering through this system will not having much pressure to open this diaphragm, and this triangle will go down, allowing free flow of oxygen from here, which will open a whistle at end of this path, giving an oral alarm to us that there is a problem within the pressure. Sometimes some machines doesn't have this oral alarm and they are having the light alarm and this annoying sounds on the monitor that there's a problem in the oxygen pressure failure system. But in old and classic machines like CE, if the flow pressure falls below 25 psi, you will hear this whistle like like this. This is exactly the sound of this alarm. The third pathway through anesthesia machine for oxygen is this part, the oxygen flush valve, which is connecting directly, and here that the pressure of 45 psi to the outflow. It will The activation of this valve will deliver a pressure of 45 to 50 psi to breathing circuit. Never use this valve, oxygen flush valve, when the circuit is closed on a patient. Definitely, this patient will have a barotrauma, and it will deliver around 50 liter per minute, 35 to 57 liter per minute, an average 50 liter per minute, with a pressure of 50 psi to the circuit. 50 liter, 50 psi. And this is connecting the circuit to the high pressure circuit. We know that the circuit inside anesthesia machine is high in the 45 psi and low here in the 14 psi pressure of oxygen. Okay. Fourth pathway for oxygen inside the ventilator is the ventilator driving gas. We remember previously there is a connection by the high pressure oxygen directly to the room in which is surrounding the pillow of anesthesia machine. And this the pressure inside this room allowing pushing this pillow downward to deliver the gas to the patient. Okay? But during expiration, we have here a ventilator control valve, which is stopping this high pressure oxygen to entering to the pillow and allowing the expiration to fill this pillow, which will apply a pressure to the gas or the oxygen inside this canister to release this air to outside. But here this is a pure oxygen, not contaminated with other inhalational gases. Okay, and the final pathway of this of oxygen inside the anesthesia machine is through the volumeter, which is separating the high flow circuit from the low flow oxygen circuit, the 35 to 50 psi from the 14 psi for oxygen and 26 psi of nitrous through this volumeter. Okay, and here is the diagram for all the pathways: fail-safe valve, oxygen alarm, flush, and the canister here in this side, and the volumeter. In some machines like Datix Omida, they have something named uh, second stage oxygen pressure regulator, which is separating the high flow from the low flow uh, pressure oxygen, low pressure of the gas. Again, these regulators here on nitrous and on oxygen, they are separating the high flow circuit from low flow circuit. They are upstream. Upstream means before. They are before the flow meters. Downstream, which is the vaporizers, they are downstream, but this regulator is upstream, and the flow is constant. Even there is a fluctuation in pipeline, they are maintaining constant flow inside the anesthesia machine. And as we know that they are reducing the pressure to 14 psi gauge for oxygen and 26 psi gauge for nitrous oxide. We have finished the pass of oxygen or 5 passes of oxygen inside the ventilator. So how we can analyze oxygen inside the circuit? We are using this oxygen analyzer, or another name oxygen sensor, which here in Mindray at this part, or in Datix Omida is hidden under this bar, or in the dragger is above, just above the outlet of inspiratory limb. So where is the actual position of this sensor? It's at the outlet of inspiratory limb, at end of path of oxygen inside the anesthesia machine. Why? To avoid any misreading for the oxygen concentration inside the flow. We didn't put it before volumeter or after vaporizer because there might be leakage undetected or problem to these areas. So its place is visualized and maintained just before inspiratory limb. And this is an MCQ question. So we have two ways or two physical principles for oxygen analyzer: the electrochemical technique and paramagnetic technique. We should know that oxygen and nitrous oxide are the only gases which are having some magnetic features. The electrochemical technique, which are the galvanic or polarizographic analyzer, having slow response, take 20 to 30 seconds, and they also have limited lifespan due to depletion of electrolytes and deterioration of membrane. It's not maintained and need to be changed every time to time. Paramagnetic analyzer have rapid response and they are widely used and measure inspired and expired oxygen concentration breath by breath. Okay, so what is the electrochemical technique? The electrochemical technique is consist of an anode, which is something or a compound giving an electron, and the oxygen is passing through this cathode, and it will be reduced with electron. Here there is an electromagnetic field which is connected to a meter and is directly proportional to the concentration passing through this cathode. This meter will be gaining or become higher if the concentration of oxygen is higher. Okay, so release of an electron from an anode, either this could be an spontaneous in fuel cell or induced using an electric supply or electric power to induce this anode to produce its or giving its electron, like in plerographic cell. Reduction of oxygen by electron at the cathode, creating potential difference correlated to oxygen concentration. So the potential difference here is directly proportional to oxygen concentration. The more oxygen passing through this cathode, the more is the reading and the concentration read by this meter. This one is not widely used now, and it's very limited because the anode could be depleted, this membrane could be disrupted, so it's limited usage now. The one we are using now is the paramagnetic technique, which are having two devices, the Pauling apparatus and pulsed field technique. The Pauling apparatus principle is here a small mirror connected to two nitrogen balls, okay, in this room, and a light source which is reflecting to a detector, and this detector is connected to a meter. When the oxygen is passing, and this one is magnet, when the oxygen is passing through this, it will be attracted to the magnet, will make disruption to this uh, dumbbell ball of nitrogen. So the light reflection will be increasing and decreasing according to the concentration of the oxygen passing through this. So the degree of displacement of this mirror and the displacement and the reflection of this light to the detector is directly proportional to percentage of oxygen in the mixture. This is the first device, which is the Pauling. The other device is pulsed field technique. We are using an electromagnet and passes two passes of two lines of air and oxygen, and we are using the air here as a reference, which is containing 21% of oxygen. When this one, the electromagnetic is activated and the oxygen is passing here, it will create a pressure difference. There is a pole here which will be affected by the pressure difference. This pressure difference is connected to a pressure transducer, which is correlated to a meter here. The pressure difference detected by a transducer is proportional to the difference in oxygen concentration between two samples. If it's 21%, it will read 0, and like this, it will increase until 1%. This will make a pressure difference of the gas. Okay, so the pressure difference of the gas in 1% will make here a huge the 1%, 100% of the oxygen will make a huge pressure difference, which is detected by the transducer here, which will give me us the actual concentration immediately at the same time, because we are using the paramagnetic feature and physical principle of this gas, which is oxygen. So here in paramagnetic techniques, we have the Pauling apparatus and pulsed field technique. And that's the end of our lecture. This lecture is very important because we have around three written questions, which are the oxygen pathway inside the anesthesia machine, oxygen analyzer, and you could sometimes someone can ask you in oral exam regarding the electromagnetic technique, the electrochemical technique analyzer and the paramagnetic technique analyzer, so you should know them carefully. Thank you for your attention and looking forward to have new lectures soon.